Everyone, how's it going? So, this is kind of intended to be a explanation video for Cube Hamster, for his sharing is caring series, but it'll also be a kind of standalone tutorial in its own right. So we're gonna go over all the different ways that you could build wires for a two-way flying machine. It looks like there's a lot of contraptions here, but there's kind of really actually only one contraption, and this is just that same contraption reshaped to travel along different axes of movement. It's super useful, and I don't think a lot of people know about it, and I'm going to try to convince you of that by the, the video's over, so here we go. So first we'll start with what is not mine, what I did not make. This is just a simple two-way extension right here. Has a delay along the axis of extension. So while we're talking, I'll just clarify some terms. There's going to be the axis of movement and the axis of extension, which might be the same, they might be different. So for example, this one, the axis of movement is this direction where I'm flying right now, but the axis of extension is perpendicular to it. I'm going this way. So this was, I found this in a Slimestone tutorial series by avoiding, so it's very helpful, and I think it's actually way more useful than they gave it credit for. And then you can reshape it a little. That's what this one is. It's just the same kind of circuit concept, but now the axis of extension is collinear with the axis of movement. So instant retraction, you can meddle with it a little bit, so it's actually even delay both forward and backwards, but this will do for the purposes of the explanation here. And, well, classically, most wires on flying machines were actually instant buds. That's what I found in tutorials, and that's what I see most people fiddle with, and it's kind of problematic and not that useful. So it is nice because it's instant, but I found that a much easier way to go about things is just to use observer wires. So it's a little setup like this, piston, observer, kind of thing. And it's nice because you can put both of these onto this two-way extension. So for example, here's the observer wire. It jitters a little bit, but it works just fine after it's moved. And then you can do the same thing with the bud wire. It jitters also, a little bit longer, a little bit more jittering. You can see just in the compactness that there's already an advantage for the observer wire. Here, the highest we're getting in component size is 6 blocks, so we still have plenty of room with the 12 block push limit here. I think we're hitting 10 and 11 now, so we don't really have wiggle room left over for maybe we need to take like a turn at a 90-degree angle or connect this to another component at the end. But then there's another advantage that the observer wire has, which we demonstrate right here. So since they jitter, you'd think you could only run the wire opposite the direction of extension. So here the extension updates from near end to far end, and the wire runs from far end to near end. And if you did it the other way around, where the wire was running from the near end, which updates first, to the far end, which updates last, you might accidentally try to move the wire while it's extended. And that does in fact happen with the bud wire. So the bud wire can't handle that. This component is extended at the time at which it's supposed to be moved, and so it doesn't get moved, and it's just a little problematic. The observer wire, on the other hand, is actually just the timing works out such that it has no problems sending a signal along in the same direction along the same axis of extension. So very useful there. And what that means is you can actually make a pretty compact, so this is just 5 by 1 horizontal footprint bidirectional wire. So extend this, so it's just fine. It's same extension with a couple blocks added on the side. And now we have wire going this way and wire going that way. So very useful there. Then you can also extend this thing vertically, so perpendicular to the axis of extension. It's perpendicular vertically instead of horizontally. So here's one possible rearrangement, and another possible rearrangement. So again, all these are just rearrangements of the same two-way extension. So the only bread and butter I'm really presenting you with here is just this idea that observer wire and avoiding this two-way extension are a match made in heaven for each other. There's no extending while trying to be pushed. It all just works out really well. So then right here I have an example of putting, so this is bidirectional wire again, except now the wire is running along the direction of extension, or well, the direction of extension is along the direction of movement, axis of movement. And you can see there's some jittering. In the contraptions I've used this for, I've solved the jittering problem by just whatever circuit or secondary contraption gets activated by this wire, I just make sure I move it after a long enough delay that all the jittering is stopped. It's moved to place and can potentially be activated by this. And then same thing again. So this is direction or axis of movement is perpendicular to axis of extension, and we're doing it vertically this time. Same thing. It works perfectly well. What I'm not covering here is if you're trying to actually move up and down. So this does not cover vertical two-way flying machines, but this covers all possible kind of permutations of wire direction, extension direction, and movement relationship for a horizontal two-way flying machine. Where is it? Here it is. So if you want to, you can also set this up so that there's no jitter. So instead of moving the piston and a power transfer block and the observer on one component, you split it up so that the observer is on a different component. Now you can move the whole thing without any jittering. The kind of downside of this is that now each one of these components on the left here is taking up the full 12 block push limit, so you just have a little bit less wiggle room to work with. And just as an example of what this can be used for, here we have a flying Turing machine. It's 4 states, 2 symbols, so actually kind of the proof of concept in itself that you can do any sort of computation you need on a flying machine. Start this up. This is the mechanism that goes right left. I'll give this thing a video explanation in its own right. I've been putting it off because I want to make sure it's a really good explanation. You can see on here we have a bunch of these wires. So here we have, sorry about all the noise. We have a vertical wire and a vertical two-way extension, just like that. On top here, we have the same thing. You can see here we actually have these wires taking 90-degree turns on top, so even flexible enough to do turns easily. Bunch of these on the side, bunch of these inside the kind of programming card nexus in the middle. We're using these in the center area, which sends the appropriate pulse from the memory tape through the machine. So yeah, I think they're pretty powerful, and I haven't seen them mentioned in any other Slimestone tutorials or builds, so I think they're pretty cool. Thanks for watching. Your Sharing is Caring series goes well, Cube Hamster. I'll see you later.